Hello and welcome to the Daily Space for today, Monday, December 2nd, 2019. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Now, we're all coming back from holidays. We're all coming back from, everyone here in the United States is coming back from the Thanksgiving holiday. There's snow and bleakness everywhere. And let's face it, last week there just wasn't a lot of astronomy news. But there was one story that worked rather hard to try and, rise up above the noise. And this particular story is one, if I can transition the screen, we're going to do a Monday here. There we go. And this particular story is one of a potential massive black hole. Now, I'm not talking supermassive black hole like we tend to find in the centers of galaxies. I'm talking about a 68 solar mass black hole right here in our galaxy that is discussed in a new paper in the journal Nature. This research comes from a team led by Lu Zhejing of the National Astronomy Observatory of China, and they're announcing that they think they found a black hole by looking for the anomalous motions of stars that indicated the presence of a dark companion. In this case, they were able to see a star that they assumed to be about 8 times the mass of our sun, that is orbiting an unseen object every 79 days. While the size black hole is weird by itself, what makes this result really weird is their belief that this black hole would have formed through the death of a single star. You may have noticed that I've used words like potential, belief, and assume. This is because this is one of those papers in Nature that is possibly true, but is very easily very wrong. Both the journals Nature and Science publish things that are potentially groundbreaking Nobel Prize winning results, or just preliminary and not yet fully baked. I'm not sure what percentage of papers are later proven wrong, but it's a high enough potential that folks actually joke about it. So what do we need to worry about with this discovery? The presence of a dark object of some kind isn't in doubt. They've seen a star orbiting something regularly using multiple telescopes. This is essentially a binary system where we can measure the period well, but struggle to get at other needed information like the size and inclination of the orbit. They make estimates of the orbital size based on an assumed distance, which is based on an assumed star type and luminosity. And that's a whole lot of assumptions. And they correctly point out in their paper that interpretation of an extraordinary 70 solar mass dark mass will be undermined if the companion mass is substantially lower than 8 solar masses. That 8 solar mass size came from looking at a combination of factors, including its temperature and surface gravity, which is an indicator of its size and also really, really hard to measure. In order to match this size of a star with the observed brightness of the star has to be quite far away, about 14,000 light years away, which made the black hole really big. The thing is, according to Gaia mission data, this particular star is only 7,000 light years away. Using this new distance and everything it entails changes the black hole mass all the way down to 10 solar masses, which is a totally normal mass for a stellar mass black hole. But what if their distance is correct? Well, now we have to think harder about this being a black hole that was generated by a single star. If it was from a single star, it would need to be a star with an initial mass of something like 200 solar masses. And we haven't seen that yet. We haven't even seen 100 solar mass stars. But maybe this star comes from a time when stars could form much larger. And it just happens that it captured a much younger star and now lives in a generally youthful part of our galaxy. This is possible. It's also possible this black hole had a more complicated origin and formed through the merger of smaller but still massive objects, such as two regular black holes or a black hole in a massive young star. We know this happens. LIGO has measured gravitational waves from this kind of object, but it's unknown if this particular system could have formed and settled into its observed circular orbit in the needed time. And here's the thing. All of these, it could be possibilities, are raised in the Nature paper that led to so many news articles. The thing is, all these it could be possibilities don't make as clickbait of a headline or as exciting of a story, so the lead gets buried. The other thing is, all those stories failed to highlight one of the most exciting parts of this study. This team is finding black holes that are unlike anything we found before. They are boring black holes orbiting non-disrupted stars. They aren't giving off X-rays or gamma rays. They are just being large and dark masses. And they're getting found because of how they fling around their neighbors. This is new, and this is going to give us an entirely new census of what large hidden objects are out there waiting to not be seen. And that's kind of awesome. Okay, that story was a bit challenging. Let's switch to something entirely different as a palate cleanser. In two new papers led by Nicholas Heavens, and I have a new story to highlight the new story. I have a new picture to highlight the new story. In two new papers led by Nicholas Heavens, planetary scientists look at how dust is lofted into the air during Martian dust storms. In 2018, which is the storm that we're looking at in this graphic, a massive storm enveloped Mars, thickening the atmosphere with light-blocking materials that caused the Opportunity rover to lose power and eventually lose its digital life. While we were all hurt to lose Opportunity, the wealth of other missions at the Red Planet allowed us to use that storm to study Mars dust storms in general, like never before. Data from the Mars Reconnaissance Orbiter found that dust towers rose to heights of 50 miles or 80 kilometers. These are maybe best understood as stationary dust devils. And these systems were able to pump dust in the atmosphere for more than 3 weeks. In addition to cloaking the world with dust, these storms have a devastating effect on the water on Mars. Water trapped in Mars dust gets released to form wispy clouds and is lofted with the dust into the upper atmosphere, where sunlight can break down the water molecules and allow the individual oxygen and hydrogen atoms to escape into space. This channeling of moisture may have played a role in stripping Mars of its early water, accelerating the desertification of this once wet world. This kind of a planet-wide storm is something we luckily don't have here on Earth, and understanding them is going to be imperative to figuring out how we can someday survive on Mars. So, we're one step closer. One step closer. And finally, I'd like to remind you that Comet 2I Borisov is continuing its journey through our solar system. This month, it will make its closest approach to the sun before heading out toward the great unknown. This is an active comet with a quickly growing tail that now stretches 100,000 miles. It was most recently imaged by the Keck telescope, and this is the image that we're showing you here. There are two versions of this image in one file. I don't know why they distributed it this way. The image on the left, just nice, pretty image. The image on the right includes the planet Earth for scale. Now, the solid core of this comet is not the size of the planet Earth as this image might inspire you to believe. There is a small, probably a couple kilometers across, core that is then surrounded by thousands of miles of coma with this 100,000-mile long tail. So it's a whole lot of gas and vapor, not a whole lot of solid stuff, but it's still pretty dramatic. And that's all the science I've got for you today. I will now take your questions, and while you type those in, I am going to remind you that thank you so much. There's so many things I need to thank people for today. I'm going to remind you that the Daily Space is brought to you by you. We are sustained by your bits, your subs, your donations, and your patronage over on patreon.com/CosmoQuestX. We are a production of the Planetary Science Institute working in collaboration with Youngstown State University. We are produced by Susie Murph, and you guys are amazing. My computer won't shut up. I love you all so much. You are fabulous. So fabulous. Thank you. We're brought to you by you. And I really just want to say thank you now to all the amazing things going on. Let me scroll back. There's a baby Yoda. Oh, wow. Okay. I was not expecting that. Okay, let me scroll. I'm just going to start at the bottom and work my way up. Thank you, Fenring Just, for the sub at tier 1. We now have twin Fenrings. Thank you for Fenring for the sub at level 1. Thank you, Refs Matt, for the sub. For 8 months. That's an 8-month streak. Thank you, Wayne Johnson, for the bits. Scrolling. Thank you, Alara Sophia, for the sub. Thank you, Refsmat, for the bits. Thank you, Wayne Johnson, for the sub. Scrolling. So much awesome. Thank you, Ironheart, for the sub. Oh, I'm sorry about the double music. Sorry. Didn't mean to do that. I was busy setting up cameras. Thank you, Guido, for the sub for 19 months. That is amazing. Oh man, you guys are awesome. Thank you, Trekker Kev, for the bits. All right, so I'm going to answer your questions in just a moment. Before I do that, I just want to say we are going to be doing a massive hangout-a-thon this month. You will see a rather scary giant goal bar appear very shortly. Here beside me in the empty space that I'm pleased is currently empty. This is because we are reliant on you to keep all of our bills going. And just like the National Public Radio, just like so many other nonprofits, we're going to use December to make up the difference between the monthly donations that come in and what we really need to pay our bills. Last month, you guys, well, you made it possible for us to not just pay for our servers, but to also pay for all of our software. So you saved me from having to ask for that later. Next, we're going to, ask for you to help us make sure that we're paid too. We do have a bunch of federal grants pending that we're hoping will cover all of our science costs. And we're looking to raise money to cover all of our communications, all of, the things that we do to make sure that you get science, the things that make us a media outlet as well as a science place. So tune in the weekend before Christmas, and we will be here for 40 hours. Now, we are currently looking for corporate sponsors for, the kinds of things that allow us to say, hey, this episode is sponsored by. So if you work someplace that might be interested in sponsoring, put them in contact with us. And the other thing I want to point out is right now Facebook is doing a Donate for Giving Tuesday. Thank you so much. Thank you, Wayne Johnson. Um, Thank you. Um, so you can actually help us out by using your Facebook charity to donate to the Planetary Science Institute. The folks at PSI know that if that is coming in from Facebook, it's us. We're the ones that do that. So I don't care if, well, no, I do deeply care. I deeply care. I would be so stupidly grateful if all of you used your charity to help us out. But even if you don't help us out, help somebody out. Use Giving Tuesday. Use that Facebook feature if you're on Facebook. And I know they're kind of evil, but this is a chance to use them for good. Find an organization that you believe in, us or somebody else, and help raise money. I donate money to my local Aussie rescue because I can't bring home every dog, even if I might want to. Find something that you believe in and make the world a better place. Okay, I'm now going to answer your questions. You guys are awesome. Thank you for being awesome. Thank you. Okay. Refs Matt, your comment leaves me disturbed, so I'm going to scroll all the way up to the top and look for questions. Guido at 19 months is just so exciting. So exciting. Dutch Angle Doggo. I don't know what that means, Bad Panda. I now want to know. I'm so sorry for the double music. It's a Monday. It's a Monday. Yeah, I realized when I got down here that I had remembered to write the script, record the podcast, post the podcast, and I had totally forgotten to make slides. So I was frantically putting together the slides. Hello, everyone. Rocket Remix. Yeah, it was a thing. Let's see, looking for questions. I'm not nearly as good at starting things up as Annie is. She also gives herself more time than I do, which makes her a wiser person than I am. Thank you again, Ironheart. I'm just going to thank everyone twice, I guess. Looking for questions. I continue to love the love affair between Astra Bee and Nightbot. These are the things that bring me joy. So Fenring asks, what is the theoretical mass limit of black hole from a single star? So that theoretical mass limit comes from just how big do you think a star can get? And so far, we're looking at things that are tens of masses. Now, once you form that initial star, you need to keep that mass. And this is actually tricky. Really high mass stars have so much light being generated in their core that light pressure is causing substantial stellar winds, solar winds like ours, that are removing material from that star. There are some people that think that any star under 10 masses will lose enough of its mass that it ends up just becoming a neutron star or a white dwarf at the end of its life. So you need to start with a significant amount of mass and end up with more than 2.5 masses at the end of its life. And that just gives you a tiny black hole. To get these massive stars, or rather to get massive black holes, you have to know just how big a star can get. So far, Pistol Star is 20 some odd solar masses. It's one of the biggest that we've seen so far. We're not seeing 100 solar mass stars. So it's that limit on star mass. Now, the thing is, early in the universe, when the universe was just hydrogen and helium and trace amounts of lithium and beryllium, stars could build themselves much, much bigger. Having carbon, nitrogen, oxygen, and other heavier elements around changes the dynamics of how stars work. And that change means that stars are restricted to being smaller. But in the early universe, we don't know how stars could have gotten, and it's thought they could have been that 200 solar mass limit. But then how do they die? We haven't seen this yet. We haven't gotten to understand directly through observational data. Um, do they also have massive stellar winds? Do they burn themselves down? Do they blast themselves totally apart? So we don't know. And this is where things like LIGO, as we measure gravitational waves from merging systems, should help us build up an observational understanding of these are the things that are merging and building up into bigger things. We need to get a good handle on what the building pieces are in order to figure out, well, just how big was the biggest building piece. Random comment from Roughsmat. The toilet on the space station broke down. But hey, they did a great spacewalk this morning. Yeah. Looking to see more questions. Thank you, Wayne, for the sub. Thank you, Roughsmat, for the bits. Thank you, Alara Sophia. I just like saying your name. It feels good to say. Thank you, Alara Sophia, for the sub. Looking for more questions. Thank you, Wayne, for the bits. Thank you, Roughsmat, for the sub. Thank you, Space Dive, for the Baby Yoda. You get thanked for that one. Thank you, Fenring, for the sub. Larry asks, what gases are streaming from the interstellar comet? Is it different than the ones in our solar system? I don't remember the specific gases. I do remember that there is absolutely nothing unusual. This comet is absolutely normal, which is kind of awesome because that implies, as we've always said, that our solar system isn't special. Well, other than it has us. It's special for us, but constitutionally, it seems to be made of the same kinds of stuff that you find everywhere. So, yeah, I don't remember the details. I just remember it's normal. Thank you, Trekker Kev, for the bits. Looking for more questions. Thank you, CLU Less, for the follow. Kerbal asks, how far does humanity have to travel to not be annihilated when Sol goes nova? So our star won't go nova. Our star is eventually going to puff off its outer atmosphere. Its core is going to collapse down to a white dwarf, and our solar system is going to become enveloped in a planetary nebula. Now, when the sun bloats up to be a red giant star later on in its life, that's going to be kind of bad. When that happens, we think Mercury and Venus are probably going to be eaten by the sun. The amount of mass loss, however, that the sun will have is going to allow the Earth's orbit to expand in size. And eventually, our Earth will be far enough away that it won't be eaten by the sun. It will simply be roasted, nice and toasty. Exactly where you want to be safe, well, we're going to have things to worry about before then. The real issue is over time, as our sun slowly heats up, that's going to increase the already increasing temperature on our planet, causing water in the oceans to become water vapor in the atmosphere, triggering a runaway greenhouse effect. So we probably want to migrate before then. We have a few 100,000 years, maybe a few million. It depends on whose models you read. So the sun is not the first reason we need to abandon ship. And Mars probably isn't far enough. Von Neumann probes, anyone? Let's see what else we have in here. Oh, Bad Panda. The dog cam was at a really odd angle. I started off the stream by knocking it over. I then knocked it over again, and basically I finangled it into like barely standing up. Yeah, dog camera was totally at a weird angle. Binary Place. It's okay that your podcast version comes out way late. So Larry asks, what mass of a star that goes supernova forms a black hole that interrupts the explosion and eats it? Ooh. So you're that's a complicated way of phrasing it. So some uh, stars, while they die, their cores will collapse down, forming black holes, and that ends the light pressure being radiated away that expands out and creates the shock waves and forms elements and things like that in the outer layers of the star. So while the supernova are more abrupt, I wouldn't say they'd get eaten. They just end more abruptly than like a neutron star collapse formation instead. I don't remember what mass that occurs at. That's one of those numbers that people keep changing their mind on. Um, yeah, I have no idea. I knew it once. Don't know. Veronica Cure asks, if black holes combine, does that make them massive? Yes. So the masses add together in the process. There's some mass that's lost in the process to energy, but yes. Larry asks the US toilet, can our astronaut use the Russian as a backup? That's a question for Annie. Oh man, Mythtown, I'm sorry that you have to buy your dog a muzzle and a cone of shame. Can I recommend a donut of shame instead? They have inflatable neck things that you can get where your dog just can't move its head. It's like one of those neck braces that you get for whiplash, and it's much more comfortable for them to sleep. Um Oh man, that's sad, Binary Blaze. Not Binary Blaze, Mythtown. I was looking at Binary Blaze's response. I hope your dog gets better quickly. Space Drive asks, how do you think the development of solid state batteries will change space travel? Uh, so something has to charge the batteries. The place that they're really going to have an effect is on planetary exploration, where you have to keep your spacecraft going through the night so that it doesn't freeze to death. And nights on different worlds are different lengths. And currently, spacecraft tend to die rather brutally when it becomes lunar night. So we're going to see it in terms of it's going to make it easier for rovers and landers to make it through night. But where we really need to see advancement is in advancing ion drives for propulsion, more effective solar panels so that we can use solar panels at greater distances. And we need to turn on the plutonium manufacturing so that we can get more radiothermal generators. Not having nuclear power sources to fuel and heat our spacecraft is making the outer solar system really hard to deal with. Looking for more questions. So Mythtown asks, would it keep him from scratching at his ear? Yes, Mythtown. It would totally, a donut of shame would totally prevent him from scratching his ear. Oh, Genderloon, I did not know that. Luckily, that wasn't an issue I had. All right, so we made it to the bottom of the questions. So tomorrow I will be back bringing you more science. To give you in advance, I will be talking about the new paper documenting the differences between Scott and Mark, the two twin astronauts that, well, one was on the ground, one was in space, and just what biologically happened while they were apart. And of course, any other news that is breaking between now and then, I will bring you tomorrow at 1 p.m. Eastern, 10 a.m. Pacific. That is 6 p.m. London time. In addition to that, we are, of course, going to be, just to say it again, working to raise money, and we would love it Love it. Love it. If you would use your Facebook charity to help raise money for the Planetary Science Institute, that will really help us out. So, anything you can do, so greatly appreciated. And we will be through Twitter sharing different ways that you can get space in your hands that you can then send as Christmas gifts to people in your life. All right, that's all I've got. Wherever you are in the world, have a fabulous morning, evening, afternoon, and I have no idea who I should raid. I'll figure that out in just a moment. So, wherever you are in the world, have a fabulous morning, evening, or afternoon, and I'll see you on the other side. Bye bye.